dig little deeper into image processing. So basically today what we are going to see is like we want to generate an image based on the input pixels. So whatever pixels value we are giving, we are going to find the images whatever is created based on our input. We are also going to find it like if any pixels are already available, like whatever pixels we are giving, and in those pixels we want to set the threshold and identify the exact pixel based on our requirement. For example, we are going to create a matrix of 100 rows and 100 columns with the pixel intensity of from 0 to 0 to up to 1, 0, 0, 0.01, 0.02, 0.03, maybe up to millions of points are actually possible. So we want to create a matrix of pixels, and that group of pixels that will be ranging from 0 to 1. So obviously they are going to be grayscale pixels. So in that we want to track some pixel that should be having the value more than 0.99. It means that the picture will be very near to being white, right? White means 1 and 0 means black. So basically what we are finding is we are going to identify those pixels, those are white. And the same way, not only that, we can set the values like we want to track the the pixel that is having a very near value to black, maybe less than 0.01. So those type, how to track this one, that we are going to see in today's class. So let's see how we are going to write the code for that one. So let's write our code. So starting the code is actually very easy. What we have to do, we have to first create a matrix of random distribution we'll use. So for example, you know that what is the meaning of random. So let me increase the font size so it will be easy for you to understand this one. So if we are writing I equal to, or maybe something like m equal to, we have to give the random distribution. So random distribution we have to give means like we want to distribute these values randomly. Like for example, I'll show you here in command window. If we are creating any value of random here, you can see that random 100, 100 will generate this type of, or like 100 points it will generate, and the value will be within 0 to 1. It can be 0, 0 0.01, 0 0.02, 0 0.001. So those type of values also can appear there. So now you can see that one. So that only we want to generate here. So we are writing here random number of 100, 100 means 100 rows and 100 columns, right? So that we generated. So M is a matrix that has 100 elements. 100 elements of random distribution. Those values are from 0 to 1. So generally if you write the code like this, it automatically considers 0 to 1. Now 100 values, so it may be in fractions. Now what we have to do, we have to create an array where we want to store the values, like random values we want to store. So our first is row and column. So these are the rows and columns where the whatever values are generated now, that will be stored. Then only we can convert those in the form of an image. So then we have to find, basically what we are going to find the value of m which is greater than 0.99. So this is the value. Like what we are going to find, so values are generated, 100 pixels are available, and in that 100 pixels the values are from 0.0 to 1. So I am telling that I want to see only that pixel that has value more than 0.99. It means it will be very, it will be white. So that value we want to see. Now what we have to do, we have to go to the next line and we have to write hold on. Why hold on? Hold on command is used to, for that one, that whatever output is coming, that it will hold and then impose whatever we are getting next in that one. So that we are going to do here. So in the hold on we are going to do this. Then we want to show the image. So what image I want to show? We want to show the image that is made due to m. Whatever pixels values are there, based on their arrangement, 0, whatever the random distribution, based on their distribution, they will be converted in the form of image. Like for example, it is white, it is 1, then it will be represented white. If it is black, it will be represented 0. So those pixels will be available. Values like 0.5 will neither be black nor white. It will be in between something. So that is, so like that we want to convert in the form of the image. Then we have to plot.
Subscribe for more upcoming content.
What we have? We have rows and columns. Okay. So we'll just change this to column and row, then this as, and this as row, and then also we'll run this and see. So you can see that these pixels are tracked. Okay. So what students we have to do basically is like when you are plotting this one, you put column first and then rows, because generally in the formation of Octave, they first create columns and then rows. The arrangement becomes little correct in that case. So what happens here, you can see that whatever values I told to track, how it tracked. So let us see. You can see whatever the rounds are there, those are basically what, those are actually, they are tracked always on white color. Why white color? Because we have given the values more than 0.99. So 0.999 is what? It will be very near to white. So only that white pixels are only tracked. In case I'm telling, if you want to track only black color, so what we'll do? We will track only the values, very small value we want to track. So maybe 0.1, that will be very near to black. So that value we'll try to track this time. And this time you can see the values which is tracked now, that is black color. See, those are black color things, those are tracked correctly, right? So like this we can track the values. If you want to track something exactly equal to 0.1, let's see what happens. Are we getting any value? Only one value is there in the whole image, so that is having 0.1 value. So like that it goes like that. Okay, and that value is there, so only it's showing only one value to you. Why? Because in the whole image only one value is there that I want to see. So because of that the whole screen is black. If you are seeing some value very near equal to 1, you might be getting only 1 pixel. So like that is the logic. Now let's see, if I want to change this one, like how this image is coming now, if I want to change, I don't want O, I want something like star, then what I will do, I'll just run this code and you can see that how it is coming here. So you can see that here, you can see that the same thing is tracked, but this time with the star. So that is the overall logic. By this you can create any image based on the pixels what you are giving, and then that you will be able to track what pixels are actually in what range. Same thing, you can, instead of giving the random distribution, you can give your own image, and in that also you can track that what pixels are for what purpose. So this has many applications. Like you want to, for example, you want to identify that in the complete image, what is your area of interest? Like you want to track somebody's eyes or somebody's skin color. So in those cases, this type of codes are very important. I hope the understanding of what I am telling you, that is clear. Thank you, students.
Don't forget to like this video and also subscribe to my channel.